Hello, my loves. Guess what I have? I've got a box of rocks. I've got a box of rocks. No, they're rocks. Seriously. They're gluten-free, see? And fat-free. And they are flavored. These are my rocks. Don't question me, I'm your science teacher. These are my rocks. I dropped my rock. Okay, let me find it. Nope, I lost my rock. Oh no! How could I lose my rock? Where did it go? It rolled away. I'll find it. I found it. I found my rock. It was way over here. Okay. Here's my rock. Do you see that rock? Okay. So, what happens to our rocks when water or wind or maybe some plants would start to grow in there, or maybe some water would get in little cracks and then that water would freeze? What kinds of things would happen to my rock if that happened? It would weather, right? That's called weathering. When the rocks break down into little pieces, it's called weathering. And I have some weathered rocks. My rocks were exposed to some weathering elements. Maybe they were exposed to water. Oh, look at that. That's neat. Maybe they were exposed to wind that had little particles of sand in there that wore it down like sandpaper. Maybe, let's see if I can get it to focus. Is it focusing? Not really. Maybe it was exposed to plant roots or ice breaking it apart, or honestly, even animals with like hard hooves that kind of pound it and chip off little pieces. Or maybe my scissors, which I actually used to weather my rocks. So once my rock was weathered, it was broken down into little pieces, then it is eroded, which means it moves away. And my rock could have been like moving downstream. I'll put my box of rocks over there. It moved downstream and then it settled. Usually at the base of maybe a lake or a river. And once my sediment has settled, what's going to happen is now pressure comes along and more sediment is added on top, and then there's the weight of that sediment along with all the pressure of these coming together, and what we're going to get is a different type of rock. Now, the first type of rock, the very beginning of the rock cycle, much like candy, is melted. It's superheated, so it's completely molten. And then as it cools, it hardens into a rock. This kind of rock is completely different, and yet still made of the same stuff. So let's see. Let me get this is a two-hand job. You know, to make sedimentary rocks, it's going to take many years. Many years. Okay, there we go. There's my sedimentary rock. Now, I lost my rock again. I found it. Okay. All right, so here is my igneous rock formed from hot tamale fire. All right. Yeah, it's melted sugar in this case instead of melted magma, but it's melted sugar. And when the sugar cools, we have our hard rock. Now, when this rock is weathered and it's eroded, meaning the pieces flow downstream or they settle into a different place, they get compacted into a sedimentary rock. Now look at this sediment on my hands. You see that? All the little pieces are breaking off. And watch what happens with my sedimentary rock. What's happening with my sedimentary rock? What's going on? It's breaking apart. Sedimentary rocks are not very stable. They're not very strong. They can be broken pretty easily because really all they are little pieces of sediment, little pieces of rock that are squished together. This is my sedimentary rock. Let me get that little guy in there, okay? Come on, sedimentary rock, get in there. Squish. All right, you see that? Big difference between my igneous rock formed from fire and now my sedimentary rock. Let me move that out of the way. Okay, I'm putting this little guy right there. That's my igneous rock. Handle's in the way. Bloop, bloop, bloop. There we go. And that igneous rock has turned into a sedimentary rock. Now, what happens if my sedimentary rock flings all over the place? Now, what happens when my sedimentary rock is put under even more pressure? But now, as well as pressure, it's got heat. So pressure and heat, pressure and heat, pressure and heat. There's heat in my hands, and I'm putting a lot of pressure in there. What's happening? Let's see. Do you see a bit of a difference? What do you notice? Oh, I noticed that this one fell apart pretty quickly just by me holding it. Let me get you back together. This one stayed together pretty well. And this one, you can clearly see the big chunks of sediment. This one, the sediment is kind of holding together. Because when we add heat to this process, they tend to melt together a little bit. They stick together a little bit. But you know what? It's not a lot of heat. See how the candy, you could still see that, I'm sorry, the candy, this isn't candy, these are rocks. You could still see that the sediment is there. You can see all the separate pieces, but they are, look, my poor sedimentary rock is broken apart. But you can see that they're holding together because more pressure and then that important heat holds it together. Now, there's another stage. Okay, this is my igneous rock. Here's my my sedimentary rock, which is very brittle and breaks apart. And then what kind of rock is this? When I take my sedimentary rock and I add more pressure, plus the heat of my hand, I have a different kind of rock. Look, you can see the difference. Let me see if I can focus over there. Does that help? Not much. So what happens when you've got that? What kind of rock is this called? It has changed, hasn't it? It's no longer sediment squished together. It's now called metamorphic. But it hasn't been melted completely. It's only been melted a little bit. What happens if I take this sediment and melt it completely? What would it turn into? It would turn into igneous rock, wouldn't it? Igneous rock can be broken down into sediment and then turn into sedimentary rock. But you know what? Igneous rock can also be slightly melted and compacted together with heat and pressure and become metamorphic. And then metamorphic rock could be broken down into sedimentary rock. It sure could. Or this rock could be superheated by magma in the earth, and it would turn into what? What would it turn into? It would turn into an igneous rock. Absolutely. So I'm going to try something that I've never done before. I'm going to oh, what's happening? What's happening to my rock? What do you think? Is it melting? I'm burning my rocks. Maybe I'm too close. What's happening to that rock? It's getting superheated. And what happens when rocks are superheated? Notice some changes happening here. The rocks are becoming like almost all one color. Do you see that? And I just realized I don't know where I know exactly where my spoons are. My spoons have moved to the other art room, but guess what? I have a broken fork, and I'm going to use that. Okay. Ooh, look at this mess I'm making. It's fabulous. Now, I could probably put this maybe in the microwave. Well, not the metal bowl, but the candy in a microwave. Oh my goodness, it smells so good. In a microwave, inside a microwave-safe bowl to melt it. This could be put like in a little pan in the oven. But what you're noticing is when it becomes super heated, it's starting to melt and turn not just into a metamorphic rock, which is kind of what's happening right now, huh? This is a metamorphic rock. You can still see the different rocks. Oh my goodness, it does smell so good. Let's see if we can heat this metamorphic rock into an igneous rock. All right, you guys have a crazy science teacher. Ooh. Do you see that? Look. Look, see how it's turning into magma? Oh man, this is awesome. All right, we're getting there. Look, woo! So it's still heated, and it's still a metamorphic rock. So you know what? I'm going to check back in with you in a second, and let's see if I can melt this a little bit more gently, and see if we... Oh, this is so much fun to play with. And let's see if we can turn this into molten lava. Okay, so I have managed to make a huge mess in the name of science. And here I have my new igneous rock. I'm going to put this over here. Bloop, bloop, bloop. My igneous rock, and then you can see where it had become quite molten, but it's already cooling off. That molten rock. Move that out of the way. Okay. So here we have the candy cycle, the rock cycle. Sorry, it's that. Those are rocks. We have something that started off as it was an igneous rock, right? It was superheated and then cooled. That rock that broke down into little pieces. Those pieces joined together to create sedimentary rock, but you can still see those pieces. See those pieces of rock there? Yeah. And then that sedimentary rock, uh-oh. Hold on. That's the sedimentary rock. This is what kind of rock? This is that metamorphic rock, right? It was heated and pressurized and squished together. So it looks quite a bit similar to that. Let me get you guys out of the way. There we go. Knocking things over. And then once a rock is superheated and it goes back into its molten state, when it comes out and it cools, it's an igneous rock, right? So here's my igneous rock. It looks like a rock, actually. That's the only one that looks like a rock. All the others look like candy still. Okay. So, I found this idea on YouTube, and I saw somebody do it with jelly beans, and I saw somebody else do it with Starburst. And I happened to see this. This is my dad's. Don't tell him that I took his candy. I'm just teasing. He probably opened this a long time ago and he doesn't remember he has it. So there was just a few pieces in here, and I figured, well, instead of, throwing it away, I'm going to use it for science. But on YouTube, I did see some videos where they used Starburst, they used jelly beans, Um, what else did I see? I don't know, but I thought, it would be really cool. Chocolate. That would be dangerous because you know me, I'd probably be eating all the chocolate and not really doing my science experiment. So, this has to be done with an adult because we're talking about heating up our rock. So you can, you could do the sedimentary parts, but this kind of thing, when you're working with heat, that's when you want parents. And I'm going to warn you right now because I remember getting grounded when I was about 14. My brother and I took now and laters and put them in the microwave to see what would happen. And they kind of bubbled over, and those little glass pans on the microwave, it got stuck there, so he and I got in a lot of trouble because we messed up my mom's microwave. And I was 14, 15 at that time, and that makes my brother a lot older. A lot older. So, don't get in trouble, don't get grounded, have a parent help you if you want to do something like this. But here's my challenge for you. Do you think you can find a way to explain the rock cycle? And maybe, you could use candy, but maybe you can think of another way. Do you remember when we talked about, let me get my, there we go. Let's get you over there. Do you remember when we talked about the tectonic plates shifting and I made a piece of artwork that showed our plates and then it showed that the asthenosphere that it sits upon? Okay, so I did an art project to show those tectonic plates. And then I have another art piece that I made, and this is called Pangea. Because Pangea is when all of those continental plates were originally stuck together before they started to separate. So Pangea has every continent in the world pushed together, and then they started to separate. So I used paint to show this. And then I used candy to show this. And I have candy along with some paint all over my art table. Here's my challenge. I want you to find a way to describe the rock cycle to someone. You can draw a picture. You can draw a comic. Ooh, that would be kind of interesting. I know Artem's really great at drawing comics. You could maybe draw a picture of the rock cycle itself. Maybe if you happen to have a couple examples, maybe if you're a rock hound and you collect rocks, you can draw a diagram and put your rocks on it. Maybe you can invent a board game where, you spin the spinner and you land on metamorphic rock and it says, oh, you're metamorphic, so go forward 3 spaces because, I don't know, pressure and heat. Or go backward 3 spaces. Oh, that rock, listen. So think of a creative way to explain the rock cycle. All right, guys. This was fun. I made a lot of mess. And it smells amazing. And I'm not going to lie, I really want to taste this. But I won't. Okay, I love you guys. Bye.